Welcome to day 3 of your Xerox Igen4 training. In day 1, we started talking about the paper path, and then we moved on to day 2, where we talked about the xerographic components and the fuser components. And day 3, we are talking about software. Oh my god. I already recorded this video a couple times and it didn't come out very good. So you got to improvise. Okay. Software. So as an operator, you will be running 2 different computers. One of them is called the PSIP. The other one is called the DFE. Digital front end. The 2 computers are linked to the press. The front end uses a job manager to take in jobs from a server, set up the print jobs with the settings, paper settings, whatever settings for the job. You release the job, it sends it to the press and starts printing. The PSIP is the interface for the press that has a bunch of clickable button menus that you can click on, drop-down menus, and an active status list. So on the right of the screen is an active status list that shows you the status of the press, if there's anything the operator needs to be aware of. So Xerox has a bunch of sensors in this press. That's how they designed it. They designed it mostly to perform the function of printing. They didn't necessarily put sensors that help determine or help the operator know exactly what is needed to correct a problem. And the documentation that is provided doesn't usually help you very much. That's why we have these training programs. If you're going to get good at this press, you're going to have to understand a lot of things. So software is pretty easy. If you're familiar with a computer, you've had to familiarize yourself with software before. Same kind of thing. The DFE is easier to familiarize yourself with. You just have to be aware of what you are doing. What am I trying to print here? What settings do I need? That's the skill you develop. With the PSIP, you are interacting with the press. So you have several options on a menu. We're going to go down the list, not in the order that they're in, but we're going to start with finishing. Finishing, you can click on the finishing button, or you can click, they have a paper path diagram of the press. You can click on each section of the press if you want to pull up some option window. So you can click on the stacker, or you can click on the finishing tab button. I use words interchangeably. Whatever you want to call it. If you, in this case, we are only talking about the stacker because we don't have other finishing units. So for the stacker, there's only 2 settings that you can change. One of them is the max capacity of the number of sheets that can be held in the stacker. So I always set it for a nice even number, 2,000, 1,500. That's good for being aware of what, if you're printing a bunch of stack after stack and you go, okay, I have 3 stacks done, that's 6,000. It's easier to backtrack when you have things set nice and neat. Otherwise, it's not going to be an even number, and it's just good practice. So when the sheet hits max, or when the press hits max capacity in the stacker, it will cycle down and then drop the stacker, or actually it'll just cycle down and you have to drop it. The second setting is unload after job. So if a job is done, you can unload, you can tell the press to cycle down and just drop the stacker. So you're done. So you can remove the job manually and then close the stacker back up, and it'll go back to doing whatever is next. So on the DFE, if you release, you can release a bunch of jobs at once, and it'll go in order of the release order. But if you have this setting on, you could have it so that it stops after each job and unloads. Some operators don't like it, don't use that setting, but I do. In various situations, you might find it to be useful. Image quality artifacts can vary based on the type of paper you're using. They can vary based on the size of the paper you're using. So if I'm printing a bunch of jobs and they're not the same paper, different size, different type, whatever, I want to inspect more closely what's being printed. So I might use that setting to drop after job. Then I can look at everything, and then I can take the time to set up the next job. Otherwise, it'll keep printing as long as there are the correct paper in the feeder drawers. It'll keep printing. It can stack. The stacker can stack multiple types of paper, just one on top of the next. But if you have image quality problems that are happening, then now you've wasted paper, right? You've wasted time, you wasted material, you've wasted paper. And as an operator, you're trying to minimize that, minimize waste, maximize productivity without compromising quality. So I've worked in chaotic environments where you've had to run all kinds of things. I've tested things in different scenarios, and I found that whenever you're there are cases when it's more efficient to just drop the stacker. And some people will say, well, every time you cycle down the press, it has to cycle back up. You're wasting time that way. And it takes about 3 minutes to cycle up a press and go back to printing again. So yeah, you waste 3 minutes. Potentially more, because every time you cycle up, the press has potentially may need to adjust print quality. So potentially those sort of, it might add a few more minutes to the cycle up time. But you're wasting time, you're not wasting material, you're not wasting if you have print quality defects, you're wasting the material, paper, time, right? You're wasting all those things. The component life of the press is being wasted. So it's actually better to get it right. Now, if you have 2 stacker units, you won't waste that time, right? If you have 2 stacker units, you can have one drop after each job and have the next job continue. And as long as the job's not really tiny, you won't waste any time. If it's tiny, then it'll stop before you can unload the first stacker, right? You'll need 3, 4, or 5 stackers, maybe. No, I'm just kidding. You wouldn't really need that many stackers, but it might be useful to have a second stacker in case the first stacker breaks, because it's a big problem when you don't have a stacker. You have to use a top tray, and the machine can only hold a little bit in the top tray. It may cycle back down. It's inefficient. It's crazy. Yeah, you might want to get 2 stackers. I don't know, but okay. So that's the finishing tab. You can close that window. We're going to skip down to stock library. Stock library is so when you have your Igen, it needs to know what the paper is. It needs to have settings for a paper, and the library holds all of your papers, right? So if I say stock and I say paper and I say media and I say sheets, I'm referring to the same thing. I'm referring to one piece of paper, right? I'm talking about paper. These are interchangeable terms when you're speaking, but on this software, they have media. They refer to media. They don't use the word paper. They use media. They use stock, and those are different terms. Media refers to the paper type. The specifications from the paper. So it's 100-pound gloss text, right? That would be one type of paper. It's whatever the GSM number is. It's, that's the type of media. Now, what size is it? That's the type of stock. So you create a media, and then you create a stock of that media. So that would be 11 by 17 or 12 by 18 or whatever your size of paper is. That's going to be under your stock. So you create a media, then you create a stock of that media, and that stock is used to assign to the tray in the feeder, or to assign to the print job at the DFE. The DFE you'll be selecting from your stock library. And when I go to assign paper in this machine, I'm going to be selecting from the stock library. There's other settings that can be changed here. Transfer settings may be useful, probably useful in for everybody, but especially useful if you have environmental issues, because your facility is not climate controlled. You have fluctuations in your humidity, and that it's going to impact the paper. It's going to impact the press, and the transfer process. So when the paper goes through area 2 to area 3 and starts transferring in the middle there, what's the voltage? How much is the voltage for the transfer? Right? It's a default setting, but you may have print quality problems, and you may need to tweak the default setting for your stock. Subsystem attributes is what they call it. So you may need to increase or decrease the default number, and that's one setting you can change. So that's the stock library. From there you have the feeders. That's another tab. You can also click on the picture of the feeder drawers. It'll bring them up. Standard Igen has 4 drawers. Feeder 1, upper, lower. Feeder 2, upper, lower. You can click on the individual drawer, and then you will have a drop-down menu that points to the stock library. Well, which stock is it? I want 80-pound gloss cover. Okay, I assigned it to the tray. Save. Now it's programmed in the tray. Now I can load it into the tray. If there's already stock in there, the tray will automatically lower and unlock once you've changed it, because it doesn't want you to get confused. Take the old paper out now. And essentially take the old paper out, put the new paper in, store the old paper somewhere safe, close the thing back up. The tray will rise back to home position, ready position, and then you can do that for all 4 drawers if you have to. So there's 2 ways to do that. Either you click on the drawer that you're talking about, or you can go from your stock library tab and actually pull that stock and then click and drag it to the appropriate feeder drawer, and that will automatically assign it. That'll automatically program. Okay, so that's that. That's finisher, stock library, feeder. Let's do administration. Administration tab is a log. It's an event log. It has when you cycle up a press, it has a timestamp and stuff. It also contains some extra information that you might not get anywhere else. Sometimes it's useful for an operator to use the administration tab when they have print engine faults or some other component faults showing up on the active status list. Xerox didn't have it very specific. It'll say print engine fault, but won't tell you what's going on. What is this fault? But if you go to the administrative tab, you can look in the log and it might tell you something useful. Oh, it's talking about a sensor magenta developer or something. It gives you a clue to where to look, because a print engine is very vague, right? What are we talking about exactly? So you can use the administrative. It keeps track of your impression counts. It keeps track of your event logs. That's that. Like I said, there's not a lot of documentation. The next tab down is the help tab at the bottom there, and that is the documentation that Xerox provides the operator. There's a lot of terminology that you can learn here. It gives you some examples. It gives you some information. It's good to read, but it's not sufficient to train an operator. It is missing a lot of information. It is missing a lot of information. It's really not super helpful. And that's why we have these training programs. So that's help. The one big one in the middle is diagnostics. That's the one that I'm going to spend most of the time talking about. Before I do that, I want to talk about when you first get to the PSIP, right? You have all this, it's an interface with menus and clickable things. But there's also an account login. So when you log in, Xerox already has 5 different accounts that you can log into. One of them is operator mode. One of them is cust act or customer account mode. One of them is PSP mode. The other one is internal mode. And then finally SA or system administrative mode. Okay. So I'll just go over those real quick. Operator mode gives you basic operation of the press. You can assign paper, you can pause the press, you can start the press. You cannot do any diagnostics at all. So any maintenance, you don't have access. So it's basically somebody that would babysit the press only, and as soon as something went wrong, they'd have to stop and call for help. So it's really not practical in a print production environment to even have that mode. The next step is customer account. That's what everyone uses. All the customers of Xerox are using. So you have access to diagnostics. The difference is that there are some things in diagnostics that you don't have access to. PSP is Principal Service Provider. That is the Xerox support staff that comes in to service the machine. If you have a problem, you can't resolve it on your own, you place a service call to Xerox, and they will give you whatever, an ETA estimate. They will come send a technician to service your press. And essentially they will, whatever you're logged into customer account, they will come in, they'll log into PSP, Principal Service Provider. The difference is they have more access in diagnostics. There are more NVM settings, I'll get into that, that they can change. They have the ability to monitor certain things while the press is running, which doesn't exist in diagnostics for the customer account. But they don't have full access even. So above them is the internal account. That is for the Xerox engineer level. So the Xerox has their own support system. If operator calls Xerox for support, they come in, they start working. If they're struggling to figure out what's going on, they call for support. If that support is not sufficient or it's not working, everything they're trying is not working, it'll get escalated again, and the engineer level will come actually to see what's going on. And they will log into the internal account. That's the engineer level account. So it has the same access as PSP, except more. It has more diagnostic function. It has a whole bunch more NVMs, which are setting changes that you can do. Beyond that, internal is SA, System Administrator. That's for programming. That's for the programming side of things. So, nerds, just kidding, just kidding. Okay, we're going to move on to diagnostics. Okay, so you're in customer account. You click on diagnostics. You know, if you're running the press, it's going to say, are you sure? You shouldn't be doing it when you're running, but if you have to, are you sure? Yes, it'll stop the press, and then the diagnostics window will open. This is another window with option menu, drop-down menu options. NVM values can be changed. These are very specific settings. You know, if you're changing the default setting on anything, you can go to the NVM option. There's one for every area of the machine, the feeders, the stackers. You're not even going to touch those. You will touch PWB, which is referring to the print engine. Your xerographic components are where is very important part of the whole process. So diagnostic procedures are run here. The PWB drop-down menu, you have a whole list of diagnostic procedures that can be run. Some of them you will not ever touch. I'm not even going to talk about them. But there are some that you will use frequently on a regular basis. Anytime you do maintenance on the press, especially major maintenance, if you're replacing consumables, you're replacing parts that affect image quality, you probably, or you may need to do stuff here. If you're replacing the PR belt, photoreceptor belt, then definitely you're going to be using diagnostics procedures. Every time you do a PR belt change, you have to do belt capture, you have to do xerographic setup. Yeah, color maintenance eventually. We'll get there. Okay, so let's talk about some of these diagnostic procedures. Again, in the maintenance video, I'll tell you exactly how to do these, but I'm just going to tell you, just going to talk about them briefly, one at a time here. So one of them is called Job Exerciser. That is a print of test patterns. You can run it, you just select your stock, you select the test pattern, and you select your quantity, type in your quantity. So if you've done a whole bunch of maintenance, it does take a little bit of time for the press to clean itself up or get to a happy level. It has to, you know, adapt a little bit to the changes. Xerox recommends running 200 sheets of test patterns through the press every time you do major maintenance. So you can use the job exerciser to do this, or you can just run a job from the DFE with the same quantity. It's the same thing. The other thing you might use it for is to actually help diagnose an image quality problem. You might choose a specific test pattern that will kind of show you what's going on with the press. That's the other usage for it. Yeah, you know, you can print like high coverage stuff, full coverage on whatever size sheet you want, halftones, different types of halftones to see where the press is. where it's struggling, each color, So that's what you would use Job Exerciser for. The technicians will use it too after they've done heavy maintenance. Some things take time. Even the fuser has, if you change a fuser roll, it takes a little bit of time for the oil to coat on the new fuser roll evenly. So if you do any maintenance and then you go right to printing some high quality job, it's not going to look very nice. Personally, I don't use it very frequently at all, hardly at all, because I know how to avoid those scenarios. And color maintenance, I'm always running after I've done maintenance, so that helps acclimate the press. Just the number of sheets that go through. It's not 200, but it's close. I usually, if I have to run more, I'll run more. I just play it by ear. I play it by eye. I look at it, see what's going on. Okay, so that's Job Exerciser. So we'll talk about PR belt change. That's a big one. So after you do a PR belt change, I'm going to physically manually remove the photoreceptor off, and then I'm going to put a new one on. Before I do, I'm going to do a bunch of cleaning. And I'll talk about all that fun stuff in the maintenance procedures. There's a lot to talk about with PR belt change. When I put it on, I want it to be on in the right spot. Hopefully there's no damage. You don't want to damage the PR belt. That's all handling. But you want to put it on the right spot. Everything's good. Okay, I think I'm good with maintenance. I close everything up. Machine's closed up. I go. Now I have to run a diagnostics procedures. One of them is a belt capture. So it has to set up this new PR belt. So first it checks to see if there's a new belt on there. And yes, okay, there it is. It's there. And then it starts to rotate the belt counterclockwise as it normally does. And you can't see this because the press is all closed up, but this is what's happening. The belt is running, cycling as it normally does. And it's checking to see if anything goes out of bounds. So a few things can happen if you install the belt improperly. Well, first you can put it on backwards. That will fail instantly because it needs to see, it's looking to see the correct edge first, so that will fail instantly. You can, it only goes one way. Let's say you put it on the right way, but you didn't put it on all the way. It's it's mostly on the rollers, but it's partly off the roller. That's really bad. So what will happen is it may pass that belt capture check, and then it'll go on to rotate the belt, and it'll be off track, so it'll start bumping into stuff and actually damaging, tearing up, shredding the belt. And then it'll fail, and then you'll open it back up and you'll find yourself with a damaged belt. And that's sad because it was brand new, no life on it, and now it's completely useless. There's no restoring the belt once it's damaged. It's already very sensitive to damage. Even handling it is very important. But if you put it on wrong, you've lost the belt. So that's why we go through these training procedures, because it's very common in the print industry. It's easily trackable. Very common in the print industry to waste PR belts, and it can be avoided. It should be avoided. Proper operator training. Okay. So, assuming it doesn't go out of bounds, the other thing that can happen is that the belt can slide. It can slide off in one direction. It's supposed to stay in the same spot as it's rotating, but if it starts to slip, then it'll fail the self-check. You'll have to open it up and try to figure out what's going on. Probably it's the bottom drive roller that needs to be cleaned better. That's what drives the belt to begin with. If there's slippage, it's probably coming from there. Other hardware components can break and stuff, and self-checks, will give you an idea. Okay, something's wrong. You can go inspect it, but once it's good, once it passes the self-check, then you can move on to the next step. In this case, we're using Xerographic Setup as our next option. DC 951. And that does a whole bunch of stuff. I don't even know. I can't even tell you. Bill Nye the Science Guy that works at Xerox, I think, part-time. He probably knows the answer. But there's a whole bunch of sensors in this press, and they're doing a bunch of tests during a xerographic setup. It's printing test patterns on the belt, and the sensors are looking at it. So all the developer housing, each color has their own sensor. In the middle, there is a cover that is protecting 3 ETAC sensors. ETAC, Enhanced Toner Area Coverage Sensor. And then inboard and outboard of the press, you have 2 MOB sensors, which stands for Marks on Belt. So that would be your image registration. It wants to make sure when it's laying colors on the belt that they're in the right spot. Their, timing is correct. When they lay on top of each other, magenta, yellow, cyan, black, right? 1, 2, 3, 4. If they're on top of each other correctly. I mean, is anybody off? Is there skewing? Is there any, is there something wrong? The machine handles its own registration, image registration. The operator doesn't even have control. If I wanted to shift, I can shift a whole image. I can shift the entire image on the page, millimeter to the right or left or whatever, or inches or whatever. Side 1, side 2, I can do a shift all as one, but I can't shift the individual color. I can't shift magenta. I can't shift cyan. And I don't need to, because the Xerox this Igen does a really good job at getting those colors exactly where they need to be. So that's a good thing. Okay, what else we got? So the xerographic setup. Oh yeah, I was talking about the sensors. Those sensors can be cleaned. The ETAC and the MOB sensors will need to be cleaned. I usually do that every time I do the PR belt change. I do the PR belt maintenance change. I do all the other maintenance. I clean all the surfaces, and then I do the ETAC sensors last because they're very sensitive, easily susceptible to any floating developer material. And they're even sensitive to the way you clean it. So I'll go over all that later, but yeah, keeping them clean. There's a reason there's a cover over the ETAC sensors, because there's too much material in the press. It's just impossible to keep them clean all the time. And if they're dirty, it's no good. It won't run correctly. You'll have faults. So you'll run the zero graphic setup. Hopefully every step passes. You'll get to the end. Usually I'll run a mob calibration. That's another thing you could run, is a mob calibration setup, procedure, whatever. And that's the same thing. It calibrates the mob sensors, and that doesn't take too long. And then you can go from there. You can go into running colored maintenance, which is outside of diagnostics. But before I do that, let me finish up with diagnostics. Okay, so you have NVMs. Did I already talk about NVMs? Oh my God. Yeah, there are a few NVMs that you might change that help improve. You might have print jobs. That for whatever reason, the default settings are not enough to keep up. So, I've had problems with the Fuser Web speed being too slow if you have too much buildup in the X rolls. That kind of thing might be a mechanical issue, but it depends on what you're running. So if I'm running a lot of high coverage jobs, the press, let's say high coverage jobs for lots of volume, thousands of sheets or something, the press is going to struggle with the default settings. So there will be some things that can be changed. Adjusting image quality, toner purge settings can be changed so that it replenishes the developer more frequently and purges the old developer more frequently. That'll keep the developer age better. It'll help. It'll help the color. You can also decrease the interval so that it doesn't purge it frequently. I don't recommend changing default settings too often because these are well-tested settings and they're pretty accurate for the average job. But sometimes you may have to tweak things. So, yeah. Fuser web speed, like I said, so that would be the Fuser web in the Fuser that it automatically turns the web material to new, fresh material to help clean up the X roll. If there's too much buildup in there, it's struggling. Maybe it's turning too slowly. You could potentially move it to a faster setting so it turns faster. Again, these are things you could try, but you have to really know what you're doing, what your problem is before you start changing NVM values, because it may or may not even correct your problem. You have to know what you're doing. The risk with changing NVM values is you may forget what you've changed, and now you are off of the default setting. So if I change the toner purge settings to be more frequent, I change diffuser web setting to be faster, I'm wasting more material. I'm wasting more developer. I'm wasting more carrier. I'm wasting developer bottles. I'm wasting web material. But I'm doing that so that I don't compromise my image quality. I can't compromise image quality as an operator. So if I need to make a setting change, then I'm going to do it. But I have to be sure that that is what solves my problem. The problem is I might change a setting and then forget that I've changed it. So I may need to keep that setting the way it is for a few days or whatever, and I forget that I've changed it. So that opens up potential problems, right? And the PSP, I'll talk about that. So the PSP mode that the technician will log into has even more access to MVM settings than the operator. There are some things that the PSP login has access to that I believe an operator should also have access to. I think PSP and Custact should be one account because they are, all of that is potentially useful for an operator. The trouble is that when you're training an operator to run a press and the operator doesn't really know anything and just wants to play, just playing around with settings all willy-nilly, then you're potentially creating some big problems. So if you start tweaking NVM settings thinking maybe this will fix the problem, but you don't change them back after you're done, you could be affecting things that you don't realize. So if you change a setting, it's doing something. It's doing something different from the default. So if you may have a problem later, but not immediately. You say, oh, the output looks fine, but then days later, you have a problem, an image quality problem, and it came from a setting that you changed. Let me give an example. So the default setting, if you want to print on a piece of paper, it's a full coverage job, meaning it takes up the entire image of the sheet. Well, technically, it doesn't print edge to edge. It prints 3 millimeters from the edge on each side. That's the default setting. So let's say you want it to be right up on the edge. So you might change the setting. Say, I want 0. I want 1. I want 2. I don't want 3. I want to be right on that edge. I want a full bleed. You can do that, and that's an NVM setting, but what does that mean? It means that there's more toner hitting and missing. There's going to be more waste. There's going to be more. If you go right to the edge of the sheet and it goes off the sheet, where's that extra toner going? It's going on the PR belt. And now the PR belt goes around. It does its normal self-cleaning process, but maybe it struggles to keep up with all that excess cleaning. Maybe some of that material falls down onto your paper path. Maybe it falls down onto the stab blade or into the transfer DTAC, or it just free floats in the air. You have more overall contamination, right? You're making more maintenance for yourself in the long run, but you don't realize it. So it gets out of hand, right? You don't have a problem immediately, but the more you run the press, you might have a problem. So that's an example. So you might tweak a setting that causes image quality artifact problem. And now you go through your troubleshooting process for trying to figure out what is causing my image quality artifact. And you can't figure it out, right? You forgot that you changed a setting 3 days ago, 5 days ago, a week ago, whatever. You forgot. So you're going through your troubleshooting process. You can't figure it out. So you call Xerox service, place a service call. They send a technician. The technician comes in, goes through his troubleshooting process. He can't figure it out. So he's calling his phone a friend lifeline there. And you know, they're trying to go through, try this, and we're trying all kinds of things, still the same problem. We can't figure it out. We can't narrow it down. So as a last resort, they'll either send an engineer into the, you know, by this time you're into another day of trying to figure out what the problem is. They'll send an engineer to come look at it, or they'll have you reload software. So maybe there's a bug with the machine. So they'll reload the software, reinstall the software, and that sets everything back to the default settings. And hey, the problem's gone. So we don't know what solved the problem, but now it's gone. I guess there was a bug. I don't know, right? The other thing that they could do, instead of just reloading software, they could hit the reset to default button first, and they should do that. But I mean, there's no way of knowing, right? So yeah, so in that case, what has happened is you changed a setting, you forgot you changed it, it caused problems, you wasted time trying to figure out problems and materials, trying to figure out. You called Xerox, placed a service call, they wasted time and materials trying to figure it out. And it was something really stupid, like just change it to the default setting, which was already there to begin with. So you create this whole long chain of waste over something careless. And that's, you know, I think that's maybe one reason why they restrict access to being able to change these things, because of the potential disaster it could cause. But it's not a good reason to restrict access. It's a good reason to have proper training. You shouldn't be learning things that you're not ready for anyways. But yeah, that's what I'm doing. I'm telling you how to do it. Okay, so that's NVM settings. Resetting back to your default after you're done is important. Write it down. I changed this value. Write it down somewhere. Change it back later when you're done, when you don't need it anymore. You should only be changing things that you need. And generally, you don't need it. I mean, a lot of the times you really don't need them. The default settings are sufficient. That's NVMs. I think we're good with diagnostics for now. I think we're good with diagnostics. Just want to make sure. Okay, so you're closed out of diagnostics. That is that. There's a few other things to click on. There's a color maintenance tool. That would be the inline spectrophotometer in area 10 that scans test patterns printing out as you're. So you'll run color maintenance procedure. It'll it'll go through, it self-checks. It'll send paper through the press. It'll look at the test patterns, make adjustments, run some more sheets, make adjustments. It'll give you a score, and then if it's a passing score, then you can carry on. You could also run it again if you think the scores can be improved and you want to make sure they're higher. It will improve each time you run it, or it should. If it's not, you have some problem going on. So that's color maintenance tool. There's another clickable HFSI button, whatever. Highly frequent serviceable items or inventory or something. So these are the consumables that you'll be responsible for replacing. The HFSI list shows the common consumable parts, names. It'll show you the current life count that they're on, so the current number of impressions that this part, since it was last changed, has been in the press. It'll show you, and then it goes to a maximum capacity, a default interval, and once it gets close to the interval, it'll say, it'll change color from green to orange and say, warning, it's getting close. And then red means stop, change it. It's time to change it. So these are default intervals. They're not exact, but these are numbers that Xerox has tested, and that's average lifespan of each component. You will use this to reset the parts. So after you change a part, you come to the HFSI list and you'll reset it back to 0. You can also do that in the NVM settings. You can reset counts in the NVM settings, but they made it more user-friendly with the HFSI window. Okay, so that's that. Beyond that, you can shut down the press, you can restart the press. You may need to do that occasionally to fix a problem. Otherwise, I wouldn't be shutting down the press and leaving it off. I would keep a press on and leave it in standby mode or power saver mode. When you're not going to use it, it'll keep the components, the essential components on, but it'll cool everything. It'll cool down the fuser, and it'll just sleep. And when you wake it back up, it takes 10 to 15 minutes to warm it back up, and then you start doing what you got to do. There's other settings. There's like throughput settings you can change. There's something called Enhanced Image Permanence Mode, EIP mode. I don't want to talk too much about that, but essentially, it's used to correct a problem. So if you have a special kind of stock, and it's not a typical stock. It's something, exotic, linen or silk or some kind of non-standard piece of paper, runs through the press, and the press is struggling with the default settings. It's struggling not necessarily in transfer, but in fusing. It's struggling to adhere the toner to the piece of paper. So it comes in, the fuser, at whatever temperature, high temperature and pressure, melts the toner to the page, comes in the output. You inspect it and you realize that the toner isn't really on there very good, and you can easily scratch it off. That's no good, right? You don't want that. If the toner rubs off very easily, then you have an image permanence problem. And you really should avoid using enhanced image permanence mode unless absolutely necessary, because it really destroys the life of your components. The parts of your machine in the fusing area will wear down very frequently. And it's really only used for I think it's really only used for a specialty job that has low volume. You don't want high volume of whatever you're running because it will destroy your parts very quickly. Hundreds of sheets. You will have problems with fusing. You'll have problems. But essentially what it does is that it slows down the press, and so the sheet will enter the fuser at a slower rate, and it gives it more time to heat and melt on there, and that can help improve the image permanence. I've found that in those scenarios it does help, but it doesn't necessarily solve it exactly. But it is helpful. But again, if you're going beyond 100 sheets of paper in enhanced image permanence mode, it's slow, it's really slow, but it's also killing the health, it's killing the life of your consumables. So you want to avoid, it's not, oh, I want the press to be running slower because I prefer it to be slow paced. That's not good logic. No, don't do that. Or, oh, I think it's helping it's helping the quality better. No, it's not making the quality better. It helps in those specific scenarios. If you have standard stock that you always run in the press and you're having image permanence problems, EIP mode might be a quick fix, but it's not the root cause of your problem. The press should be able to handle your stock. It's when you use specialty stock that it's not perfect at that. So it might, it can handle such a broad range of stocks, but some stocks do have problems with permanence. And oil too. There can be oil problems too, but we'll get there later. Just thinking. I think we got it, man. I think that's good. Oh, we can swing back to the DFE. So you've sent jobs to the DFE. It goes in Xerox FreeFlow software. There are other alternates to FreeFlow software, but Xerox has their own software that comes with the press. You can get a different software if you'd like, but this one, you have a bunch of jobs that need to be set up with settings, paper, your output settings. You might need image quality adjustments. Hopefully not. Hopefully keeping things at default is correct. You can create queues, which are essentially a profile for profile for job settings. So you can create a queue, you can create a hot folder also on whatever computer server is sending the files. So you can even drag and drop a PDF file to a hot folder that specifically goes to a certain queue on the DFE, which already has the job settings there. So that's useful if you do the same kind of jobs all the time and you don't want to have to manually set up the job every time. You can send them to the DFE hot folders that are already created at the DFE queue. The DFE queues is what they're called. So you'll have active jobs, you'll have pending, completed, whatever, finished, whatever. And it tells you the stats for the progress for the job, how many pages you printed as it's running. When it's completed, it'll tell you how many pages printed. So it helps you as an operator. You may have to keep track of all these things as an operator, you can use these counts. You can pay attention to all that. You're gonna have to pay attention to so many things, but that's why we learn. Beyond that, you're just right-clicking, you're releasing. Once you've released, you can hold a job. You can pause the press at the DFE, or you can pause it at the PSIP. Yeah, you can rotate the sheet or whatever. There's different settings you can do. There's not a lot of settings, but there's a good handful of settings. They're basic functions. Anything beyond that should be already done, right? The pre-press that handles the files before it hits the press should have the file ready to go. It needs to be ready to print. It needs to be set up. Layout needs to be correct for printing. Those are the steps that should be taken before you even get to the press. But the press, you may have to make little adjustments here and there because of the health of the press, right? So I might print something and then I'll do a registration check. So I'm looking up to see if side one, I'll hold it up to a light to see if side one and side two are aligned exactly correct. If one of them is off, then I can make a micro adjustment on the job setting. Inches or millimeters. I can move it over a little bit, left or right or up or down, right? So yeah, and that's dependent on the health of the machine. Sometimes the machine has default settings, but it doesn't always do it exactly in perfect. There's some play there, and that's what an operator is responsible for, identifying and making the adjustments. So you're trying to minimize problems for the next step. If I'm printing a booklet, but the pages are not aligned exactly, it may not be so obvious right now, but once the final product is cut down and made into a booklet, you're flipping through and you're going, why does this page look skewed and the other page looks different? That stuff, that sort of thing, right? Oh, that's a registration problem. That came from the press itself. The file was correct. The file was correct, but the operator printed the file and didn't notice that there was a registration problem and let it go on to the next step, right? Sometimes it doesn't really matter. It's not observable to the naked eye. But if you're making these booklets, the smaller things are, the more obvious it is. If you have different designs that go right to the edge, you know, you want the white space to be even, or you want the image to be even on one side as is the other side. Otherwise, it looks off center. It doesn't look that great. So these are all things the operator is responsible for improving, getting it right before it moves on to finishing steps. But that's what you can do in the job settings. Same thing here. It's a regular computer. You can restart, reboot, whatever, shut it down. There's a process for shutting down these presses. They have to be, I think there's a special order they have to be loaded in. If you don't boot them, because they're two separate things connected to the press, one of them is checking for the other one before it continues. If it doesn't get that communication right, then it doesn't work and you have to start over, reboot it again. So you have to get the order right. If you ever have to shut down the press entirely, there is a process for bringing it back up. There's a button on the press I didn't talk about, but there's a button for a power button for shutting down the press. It's not something you'll do regularly. You may have to reboot, but you won't shut down unless there's some big problem. Usually, typically. I think we're good. So that is the software of the press, PSIP, DFE. Now you understand how to do this. You're introduced to the software. You will understand in time with practice. There's a lot of things to learn and stuff. So we'll get there one day at a time. The next videos, we're going to be talking about operation of the machine and maintenance procedures, and that I have to break up into different each item at a time, because there's a few different ones, and I need to cover this correctly. It matters. It matters how you do things. It matters to get it right, to minimize problems. So have to thoroughly cover maintenance. And once we are done with that, I mean, you are literally just practicing these and minimizing errors until you are good. And that takes months to be comfortable, years to be good. Months to know what you're doing, years to really know what you're doing, right? So, but these are, this is the correct training. Okay. I'll see you next time.